Welcome everyone again, and in today's video for sets we are going to do the last part, which is sets of numbers. If you look at the course content, you'll find that was the last part, which is the sets of numbers. We have done definitions and notation of sets, types of sets, we have done them, operational sets, laws of set algebra, we've done them, and today we are going to look at sets of numbers. And if you haven't watched these videos, I would suggest you go watch this video. That's when you come to this one, which is sets of numbers. Yeah. So just from the word sets of numbers, yeah, we just mean a set which is containing what numbers. Earlier on, I said about classes of sets, and I said a set can be sets of what, a set of what. Now this is a set of numbers. And talking about a sets of numbers, here we are going to find that we are going to talk about the types of numbers that are there. Yeah. So let's go ahead. Yeah. So the following that I'm going to mention, sets including their standard notations. Yeah. So there are types of numbers. Uh, so what numbers are there is you have heard of natural numbers, whole numbers, integers, rational numbers. So these are just the number that we are just trying to talk about. So closing this topic, you need to know what are natural numbers. So without wasting much of the time, let's start. What are natural numbers? So natural numbers are mostly usually represented by something like an n. Yeah, something like an n, but there's usually something like here. I don't know how I can write it. Yeah, but so natural numbers, these are just the numbers that are starting from, when you are counting them, you are starting from 1. Yeah, so when you usually count 1, 2, 3, 4, going up. 1, 2, 3, 4, 5. That's what, those are what we call natural numbers. You are starting from what? From 1, 2, going up. So that's the first number, which is natural numbers. So here we are going to say a set of natural numbers. So when we say a set of natural numbers, we are going to start from 1, 2, 3, 4, 5, what. Yeah, so let me write even each set that we are going to write here. We are saying a set of that number or type of number. Yeah, so even here we'll say set of natural numbers. So let's go to the second one. So the second one, which is whole numbers. Whole numbers, instead from of starting from 1, for this one it's going to start from what? From 0. So those numbers whereby when you are counting you're starting from 0 are what we call what? Whole numbers. Yeah, 0, 1, 2, going up. We are using whole numbers. Another one, which is what? Another one is integers. So for integers mostly usually represented by something like a z. So for this one, these are just we know integers, positive and negative numbers. So for those numbers we saw in natural numbers and whole numbers, we started from 1 and from 0. But this one is what? We start from what? From 0, and also we can have positive and negative numbers. If we go positive 1 and negative 2, we also have positive and negative 2, positive and negative 3, just like that. Those are what we call natural numbers. Yeah. There are other sets which we call rational numbers. So for rational numbers, we are going to find that these are numbers. For example, for rational numbers, these are numbers that are, for example, in the form. So we usually represent it something like q. Now these numbers are somehow like in fractions, like m over what? Over n. So a number and another number, m over n, such that m and n, they are what? They are integers. Now what's there is, this is equal to what? the answer that is going to be there is they are going to be what we call terminating or repeating decimals. So what do we mean by terminating or repeating decimals? They're going to have something like an answer can be 2.333, a lot of them 3333. Those are what we call repeating decimals, or 2222111. So those are what we call what? Those are what we call rational numbers. Now for irrational numbers, it's just the opposite. There are no terminating or repeating decimals after the point. Yeah, that's just the difference. There are also even numbers. I'm sure this one we know them from high school. Even numbers. So for even numbers, they are the numbers that can be in this form. They are multiplied by 2n. So on n you can put any integer here. Then you are going to find that the answer that the answer that you are going to have is numbers starting from 0, positive or minus. Yeah, this should be positive. Sorry for that. Positive or minus 2, positive or minus 4. It can be positive or minus 4, positive or minus 6, 8, 10. I'm sure you are getting my point there. The numbers that are there. Yeah, you are multiplying them by 2. For example, if you multiply 2 by 1, the answer that you are going to have is 2. 2 by 3, 6. 2 by 4, 8. You are seeing those numbers. So those are just even numbers. They are mostly the multiples of what? Of 2. Yeah. Another one is odd numbers. Let's look at odd numbers. Now let's look at odd numbers. Just as I said earlier, for even numbers I said 2n. Now for odd numbers, it's something like 2n plus what? Plus 1. Now those numbers that we are getting, for example, at first we got 0. Now when you add 1 to 0, when you say plus 1, what are we going to have? It's what? It's 1. What about we got 2 also? 2 plus 1 is what? 2 plus 1 it's what? It's 3. Sorry. We also got 4. 4 plus 1 is what? 5. We also got 6. 6 plus 1 is 7. 9. You are seeing these numbers. These are odd numbers. 3, 5, 7, 9, 11. These are what we call odd numbers. There's also another one, which is the 8th one. Another number, which is real numbers. Real numbers. So the real numbers, these are just irrational or irrational numbers. I have talked about rational numbers and irrational numbers. So these are just what? Real numbers. Now, there are also what we call number 9, which is complex numbers. Now, for complex numbers, just as I said, real numbers, it can be rational numbers and irrational numbers. So these are just ordinary numbers. 1, 2, 3, negative, 2.3, what. Those are real numbers. But complex numbers, they are in the form of, they can be in the form of something like x plus, you see this wall when you progress, you see such kind of numbers. X plus I, y. Yeah, where x and y, they are real numbers. But this I is not a what? Is not a real number. It's just something like a variable. Yeah, so those are what we call complex numbers. So those are just the sets of numbers that we have: natural numbers, whole numbers, integers, rational numbers, irrational numbers, even numbers, odd numbers, real numbers, and the complex numbers. So let's look more on rational and irrational numbers. So I already talked about rational and irrational numbers, but in this part I want to do something like examples, test examples that usually come, because they usually bring questions on rational and irrational numbers. So just as I said earlier, like rational number is a number, for example, whereby it's having terminating or repeating numbers. For example, when I write 0.25, this 25 is terminating. When I write 0.345 and this 45 is repeating, yeah, is repeating, mostly you'll find they will just put a slash and they won't put other 45 to just show that it's repeating itself. Yeah, so these are rational numbers. Now what's there is they usually ask, because an irrational number, just as I said, it can be written in this form, a, or let me just say p over q. Yeah, or let me say a over b. Now they usually ask you like, can you put this 0.25 in this form, which is what? A over b, or let me say p over q. That's the main thing that I want us to do in this last part. So the first example that we will start with is we are given 0.3, and this 3 is the one which is terminating. There is a slash on top of 3 to show that it's terminating. So for us to convert it in that form, we are going to say let x is equal to what? 0.33, because it's terminating, meaning it's repeating. Yeah. And we are going to multiply also x by 10. So we are going to have 10x. We are multiplying both sides, which is equal to 10x is equal to, this one is going to be 3.333. Yeah. Now the next step that we are going to do is subtract the 2. So we are going to say 10x minus what? Minus x is equal to 3.33 minus 0.33. What are we going to have? The answer that we are going to have is only 3. We see? So 10x minus 9 minus x is just what? 9x, which is equal to what? Which is equal to 3. And the x is going to be equal to 3 over 9, which is just 1 over 3. So our x is going to be equal to what? 1 over 3. And when we look at this 1 over 3, when we say 1 over 3, the answer that we are going to find is 0.333333. So let's look at another example. The next example is 0.24. Now for this one, we just do just as we did last time. We're going to say let x is equal to 0.2424. Since 24 is the one which is repeating, 24. What are we going to do here? Last time we multiplied by 10 because there was only one letter which was repeating, but here we're going to multiply by 100 because there are 2 letters. So we're going to say 100x is equal to, so we are multiplying by 2 so that we can cancel all of them. When we just multiply by 10, it's going to be 2.4, but we want all of them this side. So 100 by this one, we're going to have what? 24.24. Yeah, 242424. So now when we subtract the 2, we are going to have 100x minus x is what? 99x. And there we are going to have what? 24 minus 0.24, we are going to have just 24. So our x is just going to be 99 over 99 here, over 99 there, over 99 over 99. So our x is going to be what? 24 over 99. And 24 over 99, we are going to find that I think there's a number that can get in. We are going to find that the answer is what? 8 over 33. Yeah, so that's our x. So we have just converted this 0.24 into what? Into the form like a over b. So we can have as many examples, but just follow what I was doing, which is we just multiply by either 10, 100 according to the number of letters that are repeating. Now that was irrational numbers. Now let's look at irrational numbers. So for irrational numbers, just as I said, the number in a decimal whose block of digits neither terminates or repeats. It doesn't repeat or terminates. So examples of rational numbers, you may find a number just like 0.2714. You are seeing no number is what is terminating. Other examples, you can have square root of 2, square root of 3, and stuff. Yeah. Now the main thing that is usually there, the main question that they usually ask is, can you prove that a number is an irrational number? So for example, can you prove that square root of 2 is an irrational number? So let's try to solve this one. So we usually prove by contradiction. So for example, suppose square root of 2 is a rational number. Then if it's a rational number, you're going to say like root 2 is equal to p over q. Since we are saying it's a rational number, so for some p, q are integers and q is not equal to what? 0. Yeah. Now suppose both sides, we square both sides. What are we going to have? When we square root 2, when we say root 2 squared, what are we going to have? We are going to have what? 2. The square root is going to cancel. This side we are going to have p squared over q squared. And when we cross multiply, we are going to have what? 2 q squared is equal to p squared. Now if we look at it, this means that when we say 2q squared is equal to p squared, this is just mean that p squared is an even number, as it is a multiple of what? And of 2, and so p must be also an even number. So if we look at this, just as it is showing, whenever you just see it in this form, 2q squared is equal to p squared, it means p squared is an even number, as it is a multiple of what? Of these 2. It's a multiple of these 2. So it's a what? It's an even number. So we have proved that p is an even number. So we need to find also, is it q an even number? So how do we do that? We need to prove that, for example, even this q squared, we leave it alone here, then this 2 is on p squared. So how are we going to do that? We do that by equating p is equal to what? Is equal to 2r. Let p is equal to 2r. So when p is equal to 2r, we are going to, where there is p, we put 2r. So we are going to have 2q squared is equal to, what is p? P is 2r. So we say 2r. We square it. Now when we look at this, we are going to have, this is going to be 2q squared, is equal to 4r squared. Now if you look at it properly, we have 2q squared here, and 2 can get into 4. So we are going to have q squared is equal to what? 2r squared. And even q here, we can prove that q is an even number because it's a multiple of what? Of 2. Yeah, just like I said, like we just want to prove it. P was left alone and there was 2q squared. Even here, q is left alone and there's 2r squared. So which means q is also an even number. It is a multiple of 2. So this is a contradiction because it both p and q are even numbers. Therefore, root 2 cannot be written in the form p over q. It cannot be written in this form, which is p over q, because they are both what? Even numbers. So it's an irrational number. Yeah. So thank you guys for watching. This is just the end of this video in what? In sets. So if you have come to the end of this video, which means you have done, you are done with what? Sets. And see you in the next topic. My name is what? My name is Scientific Engineer David. Yeah. So don't forget to like and subscribe for more lesson videos.